Welcome to this video on alarm configuration in TI portal. So basically what are alarms? So alarms are nothing but fault information which are given to the operator by SCADA or HMI. So in this way alarm help us to reduce downtime of the machine and hence it improves efficiency of the machine. So if we design alarm system properly, so at the end it reduces overload on the machine, it reduces downtime of the machine and hence quality of the product and efficiency of the plant or machine it will be improved. So now let's begin. So here we have taken 1500 CPU and TP1200 HMI. So what we will do first, we will generate alarm, we will write a logic in the PLC to generate a alarm. So initially we will add one global DB. So in the global DB we will add one variable called alarm and data type of the alarm it will be integer. So we can take bool variable also to generate a alarm. But here what we will do, we will take a integer data type and we can access each bit of this integer data type. So here we will also add alarm conditions. So here we will add around and data type will be bool for the alarm conditions. So here if alarm condition 0 is on, then we can access each bit like this. So here 0th bit we can make it on if the alarm condition 0 is on. So we download it into the PLC. So here we will add some more alarm, some 7-8 alarm we will add. So here we can change. So if we want to access first bit of the alarm integer, simply we can put here x1. Here we can put x2. For third condition it is x3. x4. x5. x6. x7. And for 8th condition this is x8. So x8 is the first 0th variable of the next byte. So this configuration we will download it into the PLC. Yes, now it is ready. So what we will do, we will go to the HMI and we will configure the alarm. So first what we will do, first we will add the alarm view into the HMI. So we will go to the HMI alarm. So in the HMI alarm, we can add here digital alarm. Digital alarm is means this alarm has only two conditions, 0 and 1. Analog alarm, so we can give the set point, high set point or low set point. If the process value crosses the limit, then this analog alarm will be triggered. Controller alarms, so those gives alarms related to the controller. System events, if we import the system events, then system event will have communication related alarm, configuration, hardware configuration related alarm, and the mode of the CPU. But we have to import those alarms. Though, so here in under the section alarm class, we can define the class of the alarm. So class means whether we can categorize the alarm into number of classes like critical alarm, warning, or general alarm. So here let's say errors and warning, system, diagnostic event, acknowledge alarm, and no acknowledge alarm. So here error means here we will classify it as a critical alarm, and background of the incoming alarm and outgoing alarm, here it is red. So we can configure, we can change this red color to anything as per our requirement, but here we will keep it as a red only. For outgoing and incoming it is red. For acknowledged alarm it is white, and for acknowledged and outgoing alarm it is also white. So here we will change light red. So for warning it is white, so we can change it to the yellow. For the incoming, for the outgoing also we will change it to the yellow. For incoming acknowledged, so it is not, so under this by default section, so what we will do, we will add one more class for warning. Here we will give test warning. So here we will change it to the yellow, yellow, light yellow, and light yellow. For the default warning which is available here, so this so this background color of acknowledged it is not able to change, so we will add one more class here. So here we are using error and warning, or we can use critical alarm. Test critical. So for warning it is yellow and acknowledged light yellow. So here we change it to light red. And outgoing light red. So here we will use test warning and test critical class. So we will not use the by default which is available. So let us close it and let us add the alarm. So in the HMI underscore alarm, in the digital alarm, we can add the alarm. Here we can give ID, name of that particular alarm, the alarm text, the text which we want to show it on the alarm banner. Here we can add it. Alarm class. So now here we have to select our test critical or test warning, trigger tag, which tag we have to use it to trigger the alarm. Here trigger bit and trigger address. HMI acknowledgement, if we want to use the HMI tag for the acknowledgement purpose, we can use that. So here we will add our text alarm 1. So here alarm class we define it as a critical, so it will come with the red background. So here tag, we have not added tag at the moment, so we will go to the DB. We will take this alarm integer and the trigger bit it will be 0, so trigger address it will be alarm.x0. So in this way here we will drag and we will add some alarm. So here digital alarm tag name it will be, so name of the alarm it will be incremented. All the class are test critical, alarm text it is copied. So trigger tag it is copied. So trigger bit it is automatically incremented and trigger address it is also automatically incremented. So we will remove the unwanted one. And here what we can do, here we can first 4 we will take a critical and rest one we will use warning. So background of the critical alarm it will be red and background of the warning it will be yellow. So alarms are ready. So here there is one more setting. If we want to apply this background color, then we have to do one more setting. We have to go to the runtime setting of the HMI. We have to go to the alarm section and we have to enable this alarm class color. So if we enable this, then and then only background color of the alarm it will be applicable. So here one more setting is there, system events. So display duration in second, 2 seconds. So if we change this setting, then duration of the system event it will be changed. Also if we enable the S7 diagnostic alarms, then S7 diagnostic alarm it will be appear in the alarm. CMotion diagnostic alarm, if we enable this, then it will be appeared in the alarm view banner. So now we have enabled this alarm class color. Let us close it. So let us start simulation. So here one more setting I think we have not done yet. In the alarm view we have to configure what kind of alarm we have to show in the alarm banner. So basically there are three types of setting. Current alarm states, so it will give only current alarm. That means only incoming alarm, acknowledged alarm, but it will not show the outgoing or whatever the alarm went, those alarm it will not be shown in the current alarm states. So if we click on the, if we select the alarm buffer, then it will show all the alarms, means incoming alarm, acknowledged alarm, outgoing alarm, and outgoing acknowledged alarm it will show in the alarm buffer. But this, how many number of alarms can contain in the alarm buffer section, it is completely based on the type of HMI we have selected. So here we have selected TP1200. So for the TP1200, the number of alarm buffer alarm, it will be 1024. So only 1024 alarms it will be contained in the alarm buffer. So if we select another HMI like KTP 700, KTP 900, then the number of alarms which contain in the alarm buffer, the number it may be different. So third option is a alarm log. So if we select the alarm log, so under section historical data, there is a data log and alarm log. So if we enable the alarm log, the number of the data record per log, here we can set it. So type of file we can set it here, whether we want RDB file or CSV file or text file, we can set it here. Here storage path we can set it. We can store the data in SD card of the HMI, USB of the HMI, or network location also. So if this file, if we select here, then all the data which will be logged in the alarm log, it will show in the alarm view. In the alarm class, whatever the we have configured alarm class, only those alarm will be appeared in the alarm view. So here we require only test critical and test warning alarm. So here we select the current alarm states, we disable it, the pending alarms and unacknowledged alarm, and we will check in the alarm section whether we, so here we can select the log. So here we can select the alarm log. So the alarms which are coming under this test warning and test critical, it will be logged in the log file. Otherwise it will not be logged in the log file. So now everything is ready. So now we can start the simulation. So now there is no any alarm. So what we will do, we will generate some alarm. So here if we make it on, so PLC is in stop mode, let us make it on. Bit 0 is on. So here you can see the alarm number, the date and time of occurrence of the alarm. The status of the alarm is I. I means incoming alarm, O means outgoing, A means acknowledged, and the alarm text is appeared here, alarm text 1. So if you acknowledge the alarm, it will, the status change to the IA, that is incoming acknowledged, and color of the alarm, it turn to the light red. So if we make it off, then that alarm it will go off. See, that alarm go off. So here again, if we make it on, second alarm 1, I think text we have not changed. So in the here for every alarm it is alarm 1. So here we will change to alarm 2, alarm 3, alarm 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. So we save it and we start the simulation. So directly it should come the alarm 2. So it is starting, it is not started, it is compiling. So it is started. So see, the text of the alarm is alarm 2. We acknowledge it light red and acknowledged, and we change the state to 0. Alarm went off. We make on some warning. So background is yellow. If we acknowledge, it turn to the IA and light yellow. If we make it off, it should go off because it is showing only current alarm. Okay, so if we go to the setting and if we change again to the alarm buffer, then it will show incoming alarm, outgoing alarm, incoming acknowledged alarm, and incoming and outgoing acknowledged alarm. So if we now we have saved, and again we will start runtime. So here let us make first alarm on. We will make, see, the status is I and the occurrence date and time it will appear here. If we acknowledge it, the color, background color is light red and status change to the I incoming and acknowledged. If we make it 0, incoming acknowledged and outgoing, the date and time it will capture in the alarm view. So in this way we can use the alarm buffer. So again alarm 7 appear. If we make it off, I and O appeared, and if I acknowledge, acknowledged also captured. So in this way we can use this alarm buffer for alarm history as well. But based on the type of HMI, the number of the alarm which will be saved in alarm buffer, those will be differ. So the last setting, it is alarm log. So here we will save alarm log. So if we are using alarm log, then we have to check in the alarm class whether yes, alarm log is selected, and here we can save and we can so if we make it on alarm, so this alarm 9, it is appeared in the from the alarm history, and if we disable it, now if now we will acknowledge it. So select this, acknowledge 0. So you can see incoming and outgoing alarm, it will be captured in the alarm history. So if you see the on the C drive, it will be saved storage card ST, and here the log file is generated. See date and time, you can check it. So in this way we can use this current alarm, alarm buffer and alarm log. So the rest of the thing like appearance, the font, the size of the text, border, we can change as per our requirement. Here the columns which we required, the by default alarm number, time, alarm status, date, those are selected. So as per our requirement we can change it to the required number of column. So here let's say alarm status, date and time, and alarm text, if we keep it, so only those required thing it will be visible in the. Also if we want to change the header of the column, we can change it as per our customized requirement. So in this way we can configure the alarm. So here one more thing is there. If we want to, here we have used integer data type to generate alarm. We can generate a alarm for boolean tag also. So here quickly I can show you. Here alarm 0 I will add, data type is bool, and here we will add 16 tag. So here 16 bool variable we have added. So this is another way of configuring alarm. So here what we have done, we have used integer. So if we want to generate the alarms by using bool, so here we can do that as well. So alarm 0, alarm 1, alarm 2. But here what we have to do, like this we can configure the alarm, but here in the alarm HMI underscore alarm, here only integer or word tags we can access, but here we have added bool. So what we can do, simply we can change the data, we can disable the data optimized block access, so that each variable it will get its own address. So you can say, you can see the offset is nothing but the address. So if we can download this, so it will generate the required address for the each variable. See now db1, and each one is having address 0, db1, dbw0, db1, dbx 2.0. So here alarm, so we can read the alarm 0 to alarm 16 with the help of one word. So here we have to go to the HMI underscore tag. Here we can add one more alarm tag, and here we can, so instead of symbolic we can select here absolute, and here our alarm 0 starts from 4. So here db1, dbw 4. But here one more thing is we have to keep in mind. So this is conventional word how it is represented. The least significant byte, it is always from 0 to 7, and most significant byte it is always from 8 to 15. But in the Siemens, if we take a word like a db1 dot dbw0, so in the first word there are 2 bytes, dbb0 and dbb1. So dbb0 it will be on the MSB of the word, and dbb1 it will be on the LSB of the Siemens word. So first bit is always, so this 0th bit is always 0th bit of first byte, and 8th bit of this word is always 0th bit of byte 0. So here if this alarm, if this alarm 0 bit, if it is on, then here, now let us check it. We will add one more alarm. Here alarm test, we will add text, and here we will select that our alarm tag and now if you can see, it is taking by default 5.0. If we want to use the alarm 0, then here we have to change the trigger bit. So at the moment trigger bit is 0. So if we make it to 8, then it will be 4.0. See, 4.0. So we have to use this type of addressing if we are using bool variable. Now let us, I will show you, just download it. I think it is downloaded. And now let us start the simulation. So again we go to the OB and let us make it on. No, where is the alarm 0? Here. So here for the alarm, okay, so instead of, so I will put it here. So if we make it on, so this alarm 1 and test alarm, it will be fired at the moment. See, alarm 1 and alarm test. Alarm test is nothing but our this alarm. And if you see the trigger bit is 8, so the address will become db1.dbx 4.0. So dbx 4.0 is our alarm 0. So in this way, if we want to use bool, then we have to keep in mind the Siemens word, the 0th byte, it will be stored on the MSB side. So this we have to keep in mind and we have to use bool address. Thank you. If you like the video, please like, share and subscribe.